So, according to NASA, the universe could have up to 1 septillion stars. That's a 1 with 24 zeros behind it. So, this looks like a very, very, very big number, and these things can get really annoying to write out. So, that's why we introduce scientific notation. So, the way we would write this in scientific notation is 1 times 10 to the 24th power. Alright, so in order to get deeper into scientific notation, it's recommended that you know about fractions, exponent rules, and decimal places. Let's say I have 1 times 10 to the 6th power. So what I'm going to do is I'm going to move this decimal spot over 6 spots. So 1, 2, 3, 4, 5, 6. So that number looks like 1 million. So you'll notice this pattern that whatever this number is, that's how many spots you're going to move it over. So you should have 6 little loops like so. Also note that scientific notation, this part, the beginning of it, is always going to be in the form of 3 spots like this, where the decimal point is right there. So you can have, let's say, 3.46, but you absolutely cannot have like 34.6. This is not common scientific notation. So another example is 10.00 would also not work, but 1.00 would. Alright, let's do another example. Let's do 2.46 times 10 to the 4th power. So what I'm going to do is I'm going to move this decimal spot over 4 little jumps. So 1, 2, 3, 4. I'm going to have 2 zeros there. So 2, 4, 6, 0, 0. That's going to be 24,600. So when you have a positive exponent, your number is going to get a lot bigger. So what happens when you have a negative exponent? Let's say 2.46 times 10 to the negative 4. Well, if you remember our exponent rules, if we had, let's just look at 10 to the negative 4. Using our exponents, this is 1, or exponent rules, this is 1 over 10 to the 4th. This is 10,000. So this looks like a really, really small number. And if you remember about fractions and decimals, this could also be a decimal, a really, really small decimal. So when we have a negative here, we're going to have a really small number. Alright, so let's go back to this example. I'm actually going to move the decimal point to the left 4 spots, since this is a small number. So 1, 2, 3, 4. I'm going to have 0.000246. Let's do another one. Let's do 9.56 times 10 to the negative 7th. So I'm going to move this decimal over 7 spots. Alright, and there we go. We can also use this spacing method to figure out a number in scientific notation. So if we had 0.0000031, remember scientific notation is often of the form like this, so what we can do here is make this 3.10. And then this is a decimal. It's a very, very, very small number, so we know that we're going to have a negative number. But what that negative number is, we don't know. So let's count the zeros. We have 1, 2, 3, 4, 5, 6, 7. And remember, small numbers is negative exponents, so this is going to be 3 times 10 to the negative 7th. And then what you can do from here is check your answer. So you can move the decimal spot over 7 times, and you'll get this. All right, let's do that again, but this time with 0.2. How can we represent this in scientific notation? Well, we want it to be in this form. So I'm going to say 2.00 times 10, and we have a decimal, so it's a small number. So we're going to have a negative exponent. So times 10, and we only have 1 0, so that's going to be to the negative 1. And then we can check our answer. This is exactly 0.2. All right, so that's scientific notation.